everyone, I'm Parvati. Our today's topic is Floyd's algorithm. Floyd's algorithm is used to find the shortest path between every pair of vertices. It is commonly used to solve the real-time problems like traveling sales problem, etc. Uh, First, we will see the manual calculations of Floyd's algorithm. I will take an example graph as this is my example graph. In this weighted connected directed graph, we have to compute the length of the shortest path from each vertex to another vertex of the graph. First, this is the weighted connected directed graph. Weighted graph means all the edges will have some vertexes. Directed graph means all the edges will have a direction of it, and connected graph means all the vertices will have path to any other vertices in that specific graph. We can go to solving that problem. Our input matrix given to this algorithm is this matrix, which is the weightage matrix of this weightage matrix. I took it as for the self vertices, I put 0 as its distance, and known distance, I put the weightage as its distance. From B to A, I know that its distance is 2, so I put 2. For I did, there is no edge exists between any paths, any vertices. That means I will put infinity in that place. And this is the D naught matrix, which is the first matrix, first step of a solution. And we will go to the next step, which is the D1 matrix. Here D1 matrix will contain, D1 matrix will contain a intermediate of only one vertex, which is the changes occurred here is only B2C and D2C. B2C means there is no B2C, there is no edge exists between this B2C. By using the intermediate vertex A, we have a path. So we will add that weightages of B2A and A to C, which is 2 plus 3, 5. Likely we did this for the D2C also. Next, we will go to the second matrix, which is D2 matrix. D2 matrix will have two vertex as intermediate, which is A and B. Here only one changes occurs C to A, which is C to A have no vertex within it. A to C will have a edge, but C to A have a no edges between it. By using the A as intermediate, we will not find any path. By using A and B, we find a path which is C to B, B to A. Therefore, 7 plus 2 is equal to 9. I put 9 in that place. Next, similarly for D3 matrix and D4 matrix, I did it. Final distance matrix is D4. D power 4 is the final distance matrix. How I say is the number of vertices in my given graph is 4. Hence, D power 4 is the final distance matrix. I used a formula to find the distance between these matrices or solving solving this problem. The formula is D of ij power k is equal to minimum of dij of k minus 1 matrix, comma dij of k minus 1 plus dkj of k minus 1. By using this formula, I will explain only one step in this solution. I will take this D power 4 matrix, which the changes occur is C to A vertex. The value is 2, 0 of this place index. Here the k value is 4 and I equal to 2, j equal to 0, minimum of 2, 0 of 3, 2, 4 of 3 plus d of 4, 0 of 3. I substitute the values in this formula, and in this step I substitute these values by using the previous step of d power 4. Hence minimum of 9, 1 plus 6, which is 7. Hence minimum of 9, 9, 7 is 7. The d of 4 of 0, 2, it becomes 7. Now the changes occurred, which is 7. The d power 2's value is 9 and d power 4 value is 7. Hence I changed the shortest distance as 7. Now we can see that the algorithm for the Floyd's algorithm, I will send the parameter which is the weight matrix. I will name it as mat. Here which is the description of that of this algorithm to find the shortest path between the vertices. The input is weight matrix, output is shortest distance matrix. Here d of 0 I set it as the matrix mat, which is the weight matrix of the graph. I will open the for loop k equal to 1 to n and I equal to 1 to n, j equal to 1 to n, which are the nested for loops. Here I will do only one thing, which is the formula worked there. D power k of I comma j is equal to minimum of d of k minus 1's I of j comma d of k minus 1 I of k plus d of k minus 1's k of j. Now I close the for loops. When these nested for loops done their work, I will return the d of n. Here n denotes the number of vertices. Now we can go to the analysis of part of our algorithm. It will find the complexity, time complexity of this algorithm. C of n is equal to summation of I will do this for loops. For loop will have only one content. It will set the d power k of I of j's value, which is only one step, and j loop, I loop and k loop. Here I used the formula which summation of lower bound upper bound of 1 is equal to upper bound minus lower bound plus 1. Hence this I first j's loop will become n minus 1 plus 1. Here it cancels and n becomes the value. Similarly for these k loop and I loop, I done it. Minus 1 plus 1 cancel, minus 1 plus 1 cancel, I got n, hence it becomes n cube. C of n is equal to theta of n cube is the time complexity of our Floyd's algorithm. Thank you.